When you look up at the sky on a clear night and see Mars as nothing more than a tiny red point, something very easy happens inside the human mind. We begin to think the main problem is distance. Earth is here. Mars is there. And between them is a very large empty space. So we only need to build a spacecraft powerful enough, send it far enough, and eventually we will arrive. That sounds reasonable, doesn't it? Because on Earth we are used to thinking this way. If we want to reach a city, we travel to that city. If we want to cross a river, we cross the river. If we want to climb a mountain, we climb the mountain. Once we arrive, our minds naturally assume that the hardest part is over. But with Mars, that familiar way of thinking is the first trap. We often imagine a Mars mission as a grand journey. The rocket leaves Earth. The blue planet shrinks behind it. The spacecraft drifts for months through darkness. Inside there is recycled air, metal walls, the steady hum of machinery, sleeping bags fixed to the walls. Then one day, Mars grows larger in the window. The red point becomes a disk. The disk becomes a world. The spacecraft descends. Red dust rises. The engines fade into silence. And a human boot touches Martian soil. In that moment, the story inside our heads usually says, they have arrived. They have passed the hardest part. But this is where I think we are very easy to fool. Not because we are foolish, but because ordinary life teaches us a very powerful habit. On Earth, arrival usually means we have more control. Reaching the shore means escaping the current. Reaching home means we can rest. Reaching shelter before night means at least the danger has changed shape. But Mars is not a harbor, and the solar system is not a still ocean. It is not like a map with two dots on it. One dot called Earth. One dot called Mars. And then we draw a straight line between them. That picture is convenient for the imagination, but it is wrong in physics. The first thing to remember is this: nothing begins from rest. You may be sitting still right now, your hand resting on a desk, your feet on the floor. The room may feel perfectly quiet, but that stillness is only stillness inside a shared motion. You, the desk, the room, the air, the mountains, the oceans, all of it is being carried around the sun with Earth. Because everything around you shares that motion. You do not feel yourself racing along. A Mars mission begins inside that motion. It does not begin with a rocket leaving a motionless planet and flying toward a motionless target. The real picture is much stranger. One moving world throws a small machine toward another moving world, while both are falling around the sun. So the phrase going to Mars sounds simple, but it is not simple at all. We do not fly to where Mars is today. We must fly to where Mars will be many months from now. It is like throwing a ball to a person who is running. You do not throw it at the place where that person is standing. If you do, the ball will fall behind. You must throw it into the empty space ahead, the place where that person will arrive at the same time the ball does. Mars is the same. It is an appointment, not a target standing still. And in physics, if an appointment is timed badly, courage cannot repair it. This is where everyday intuition begins to betray us. We like straight lines. We like to think the shortest path is the best path. We like to imagine a spacecraft traveling like an airplane across a map. But orbital motion does not work that way. The spacecraft does not merely cross the empty space between two planets. It must change its own orbit around the Sun. Before it leaves Earth, it already has Earth's orbital velocity. After launch, it does not simply fly straight outward. It enters a new curved path around the Sun. That curve must be chosen so that when the spacecraft reaches the region of Mars's orbit, Mars also arrives there. In simpler words, the spacecraft does not chase Mars like a car chasing another car. It arranges a meeting, and that meeting becomes very expensive if you choose the wrong method. Of course, we can imagine a spacecraft like those in science fiction, engines burning continuously, accelerating forever, changing direction whenever it wants, leaving whenever it wants, returning whenever it wants. But real chemical rockets are not that generous. They are very powerful, but usually powerful for minutes, not for months. Fuel has mass. If you want to carry more fuel, you must launch more mass. If you want to launch more mass, you need more fuel, and then more structure, more engines, more of everything. Like that, the dream can become too heavy to leave the ground, so engineers do not try to fight the solar system as if it were an enemy. They are wiser than that. They use the motion of the solar system itself. They place the spacecraft onto a carefully calculated orbit, a long curve that carries it from the region of Earth's orbit out toward the region of Mars's orbit. Most of the trip is not a hard engine burn. Most of it is coasting along a trajectory. The word coasting sounds gentle, but it demands extraordinary discipline. If your calculation is slightly wrong, after many months, that small error is no longer small. It can become thousands of kilometers. You can correct the path, but you cannot behave as if the spacecraft were a car with an infinite tank of fuel. Now imagine that everything works. The calculation is right. The rocket launches correctly. The spacecraft follows the right path. Many months pass. The crew endures confinement, isolation, radiation, machine noise, and the strange feeling of knowing that outside the wall of the spacecraft is an almost unforgiving emptiness. Then Mars grows larger. The spacecraft begins its descent. Everything shakes. Red dust rolls around the landing legs. And finally they survive. They are standing on another world. That moment deserves human emotion. It truly does. But right there, a very quiet reversal takes place. The door that brought them to Mars is not behind them like a doorway in a room. While they were crossing space, Earth did not stand still and wait for them. Mars did not stand still either. Both planets kept running along their orbits. In other words, the room has rotated, the doorway has moved, and the path home is not as simple as turning the spacecraft around. This is what makes a Mars mission different from a trip on Earth. If you travel from one city to another, tomorrow you can buy a ticket and come back. The road is still there. But in the solar system, the fuel-efficient road does not always exist whenever you want it. It opens according to timing, and it closes according to timing. So when the astronauts stand on Mars, they may feel real ground under their feet. They may see rocks, dust, horizon, a dim reddish sky. After months trapped inside a spacecraft, the feeling of having a world beneath their boots must be powerful. But the strange thing is this: having ground under your feet does not mean you are free to leave whenever you want. To go home, they must launch from Mars, place the spacecraft onto a new orbit around the Sun, and meet Earth at its future position. Earth is not a lamp sitting still in the darkness. Earth is also running. Home itself must be intercepted. That is why the phrase "you can arrive but you cannot leave yet" is not an exaggeration. Mars is not a prison in the ordinary sense. There are no iron walls locking them in. There is no gate slamming shut in front of them. The prison here is cleaner than that, colder than that, and more honest than that. It is made of motion, timing, energy, fuel mass, and orbital geometry. The low fuel path that brought you to Mars today does not automatically become a low fuel path that takes you back to Earth tomorrow morning. The solar system gave you one window to go out, but the window for coming home is a different story. I like this lesson because it softens a very human illusion. We often talk about exploration as if it were conquest. We arrive. We plant a flag. We give a name. We declare that human will has crossed another boundary. But physics does not care very much about declarations. Not because it is against us, but because it does not flatter anyone. If the geometry is wrong, courage cannot fix the orbit. If the fuel is insufficient, hope does not turn itself into propellant inside the tank. Nature is not cruel, but nature is not sentimental either. It speaks only in very clear quantities: mass, velocity, energy, gravity, and time. So a Mars mission is not like a shout of victory over nature. It is more like a careful negotiation with nature. We negotiate with gravity, with orbit, with fuel, with the endurance of the body, with communication delay, with dust, with radiation, and with the enormous clock of the solar system. A rocket is not a magic wand. It is a request written in mathematics and sent to nature. And sometimes nature answers, yes, but not now. That is the hidden discipline of the whole journey. Mars is not only far away in space, it is also far away in timing. To reach it means stepping into a clock that was already turning. To stand on it means living inside that clock. You can drill the soil, raise antennas, check the solar panels, watch the small pale sun cross a dusty red sky, send a signal back to Earth, and wait minutes for the reply. But you cannot simply say, "The visit is over. Let us go home." Before human beings can return, the path home must exist first, and that is why the hardest part of Mars may not begin when we launch from Earth. And it may not begin when we land on that red surface. It begins when we realize that landing is not the final period. It is the entrance into a new commitment. The crew must not only survive the journey there, they must also survive the waiting, while the solar system rearranges itself into a favorable position for the trip home. It sounds strange, but in space, waiting is part of engineering. Patience is part of the orbit, and time is as important as fuel. Before we talk about habitats on Mars, dust storms, radiation, food, water, power, and the loneliness of human beings living on another planet, we must understand this first trap. Why can we not simply aim at Mars and fly straight there? Why is the path that looks shortest often not the best path? Why does a journey to another planet depend so much on timing? And why does the moment of landing look like an ending, when in truth it opens the harder part of the story? To understand that, we have to lift ourselves a little in imagination and look down on the solar system as a moving machine. Earth running on the inner orbit, Mars running on the outer orbit, the sun holding both in its gravity, and a small human spacecraft trying to pass from one moving world to another moving world, without wasting the most precious thing it can carry: fuel. That is where the real Mars mission begins. Let's slow down here, because this is where the usual picture of Mars begins to break. Most of us carry a map inside our heads, even when we are thinking about space. A map is comforting. It freezes things. It lets us point to one place and then another place and say, the journey goes from here to there. That works beautifully on Earth. If the city is north of you, you go north. If the river is ahead, you cross it. If the mountain is over there, you walk toward it. But the solar system refuses to behave like a frozen map. The moment we draw Earth and Mars as two dots on a page, we have already made the first mistake. We have removed the one thing that matters most: motion. Earth is not sitting quietly in space, waiting for us to launch a rocket. Mars is not waiting either. Both worlds are moving around the sun, not casually, not a little, but constantly. And the word orbit can be a little misleading if we say it too casually, because an orbit is not like driving around a track with an engine running. It is more like falling, but falling with enough sideways motion that you keep missing the thing pulling you in. Earth is pulled by the sun, but Earth also has sideways speed. So instead of dropping straight into the sun, it keeps curving around it. Mars does the same thing farther out, slower, wider, on a larger path. Nothing is nailed down up there. Nothing is waiting politely for the astronaut. Here is the small fact that quietly changes the whole mission. Earth goes around the sun in about 365 days. Mars takes about 687 days. That means Earth is on the inside track and moves faster. Mars is on the outside track and moves more slowly. So the distance between them is not one fixed number. It changes all the time. Sometimes the two planets are on the same side of the sun. Sometimes the sun is between them. Sometimes Earth is catching up. Sometimes Earth has already passed the useful arrangement. And this is where the simple question becomes less simple. How far is Mars? I know that sounds like it should have one clean answer, but it does not. The honest answer begins with another question. When are you asking? That is already strange enough. But the next part is even more annoying to common sense. The closest moment is not automatically the best moment to launch. On Earth, that feels backward. Close usually means easier. If the store is closer, the walk is shorter. If the boat is closer to shore, the crossing feels safer. So the mind naturally asks, if Mars is closest now, why not go now? And that is a good question. It is exactly the question we should ask. The catch is that Mars will not stay where it is while the spacecraft is traveling. If you aim at the place Mars occupies today, then months later your spacecraft may reach that empty region, and Mars will already be somewhere else. A Mars mission is not aimed at the planet as it appears in the sky tonight. It is aimed at a meeting point in the future. That future point does not look like much when you say it out loud. It is just a calculated place in space, a place where Mars is not yet. But if the calculation is right, Mars will arrive there when the spacecraft arrives there. That is the trick. You are not throwing the spacecraft at Mars. You are throwing it at a future appointment with Mars. And if that sounds odd, think of something much smaller. If a person is walking across a field and you want to throw a ball to them, You do not throw the ball at their feet. You throw a little ahead, not because you are being clever in some mysterious way, but because by the time the ball gets there, the person will have moved. Now make that simple idea enormous. The ball becomes a spacecraft. The walking person becomes a planet. The field becomes the space around the sun. And the penalty for being wrong becomes very expensive. A ball can miss by a meter, and we laugh. A spacecraft can miss by thousands or millions of kilometers, and the mission is in serious trouble. So the target is not Mars in the present. The target is where Mars will be later. That one shift, from present position to future position, is one of the most important mental corrections in the whole story. But even the ball example is still too simple, because a spacecraft is not flying through empty space like a bullet through still air. Before it ever launches, it is already moving around the sun with Earth. It already shares Earth's solar speed. It already belongs to Earth's orbit. So when the rocket fires, it is not merely pushing the spacecraft outward like a cannonball. It is changing the shape of the spacecraft's path around the sun. That is the part worth holding in your mind. The rocket is not just making the ship go farther. It is reshaping a solar orbit. You could try to force the trip, at least in imagination. Burn a huge amount of fuel. Rush outward. Chase Mars aggressively. Then burn again to slow down when you arrive. Physics does not forbid every such idea in principle, but engineering immediately starts asking uncomfortable questions. How much fuel? How much tankage? How much structure? How much heat shielding? How much risk to the crew? Every extra bit of speed has to be paid for, and the payment is fuel. But fuel is not a magic number written on paper. Fuel is mass, and mass must be launched. The more fuel you carry, the heavier the vehicle becomes. And the heavier the vehicle becomes, the more fuel you need just to move the fuel. This is how brute force starts eating its own tail. So the useful path to Mars is usually not the dramatic path. It is the efficient one. The spacecraft gets a carefully chosen push, not a wild shove. That push places it onto a stretched orbit around the sun, one that begins near Earth's path and reaches outward toward Mars's path. Then for much of the trip, the spacecraft coasts. That word can sound lazy, as if the spacecraft is doing nothing. But coasting in space is not laziness. It is commitment. The spacecraft is following the curve created by its speed and the sun's gravity, and that curve was chosen months in advance. A tiny error early on can grow into a large miss later. So this quiet part of the mission is not casual at all. Now the phrase launch window starts to make sense. It is not just a date someone circles on a calendar in mission control. It is not a convenient weekend for the planets. It is a short period when the geometry is finally useful. Earth has to be in the right place. Mars has to be ahead in the right way. And if the spacecraft leaves now, not too early, not too late, then the long curve can meet Mars later. Miss that window, and the rocket may still be powerful. The crew may still be trained. The supplies may still be packed. But the geometry has moved on. That is a hard thing for human pride to accept, because we like machines that obey immediately. Press the button. The engine starts. Turn the wheel. The car turns. Set a date. The trip begins. But interplanetary travel does not fully belong to our calendar. It belongs partly to the planets. You can build the rocket, train the crew, test the engines, simulate the landing, prepare the food, Check every valve and every wire. And still the best answer may be, wait. Not because people are timid, not because the mission lacks courage, but because leaving at the wrong time costs fuel you may not have, and once the spacecraft finally leaves, it carries that compromise with it. It does not shoot straight across a drawing of the solar system. It follows a long arc. It may spend 6 months, 7 months, 8 months, sometimes more, depending on the mission design. The voyage is long not because humans are weak, and not because engineers forgot how to hurry. It is long because the path that saves enough fuel to make the mission possible also takes time. In space, efficiency is not a decoration. It is survival, and now the trap begins to show its shape. The same method that helps us reach Mars also ties us to timing. We do not simply leave when we feel ready. We leave when the moving arrangement allows an efficient meeting. We do not simply arrive because Mars was once close. We arrive because months earlier the spacecraft was aimed at the future. And if going to Mars depends on that moving arrangement, then coming home must depend on another moving arrangement too. That is the part that makes arrival so deceptive. Landing looks like an ending, but orbital mechanics treats it like a pause inside a much larger rhythm. So the real lesson is not that Mars is merely far away. Far is difficult. Of course it is. But far is not the deepest problem. The deeper problem is that Mars is moving. Earth is moving. The spacecraft is moving. And every useful path is a timed path. We have to think less like travelers on a road, and more like people trying to step from one moving track to another. Not just where is the destination, but where will it be? Not just how far, but how much energy. Not just can we go, but when does the universe make the route affordable? That is why Mars travel is not mainly a problem of pointing harder. It is a problem of thinking correctly. We have to trade the flat map in our heads for moving geometry. We have to trade straight lines for orbits. We have to trade impatience for timing. And when you see it that way, a Mars mission becomes less like a heroic dash across empty space, and more like a careful attempt to enter a dance that was already happening before we arrive. The planets are already moving. The clock is already turning. We do not command that clock. We learn how to leave at the moment when it briefly allows us to go. It may give us a path to Mars, but it never promises that the path home will be waiting when we get there. When the spacecraft comes down onto Mars, I think the first feeling inside the crew is not a formula, not an orbital diagram, not some clean engineering sentence. It is something much more human. We made it. After months inside a small metal cabin, listening to the steady sound of machines, watching Earth shrink behind them, watching Mars grow larger ahead of them, the sight of red ground below the window must feel like the end of a very long story. There is a horizon, a pale sky, dust rising under a weak sun, and the shadow of the spacecraft lying still on another world. The landing legs touch the ground. The body of the vehicle trembles. Red dust spreads outward in a slow ring, and then everything becomes quiet. For one short moment, the people inside are allowed to think, "We have won." But this is exactly where physics wakes you up. Because in space, arriving somewhere does not mean the problem is over. It only means the problem has changed shape. You are no longer asking how to reach Mars. Now you have to ask a harder question. How do we leave Mars at the right time and meet Earth again? That sounds simple at first, But pause for a second. On Earth, if you walk into a field, you can turn around and walk back. If you drive to another city, you can refill the tank and take the road home. If you sail to an island, you can point the boat back toward the coast. But in interplanetary travel, the road does not stay behind you. The road is moving. The place you left is moving. The place you reached is moving. And the sun is holding everything in one enormous turning dance. The spacecraft reached Mars because it left Earth at a very special time. Earth was in the right part of its orbit. Mars was in the right part of its orbit. And the flight path was chosen so that after many months, the spacecraft and Mars would arrive in the same region of space together. But while the spacecraft was traveling, the planets did not stop and wait. Earth kept running along its inner orbit. Mars kept moving along its outer orbit, and the geometry that opened the outward road had already slipped away behind them. That is the hidden trap of a Mars mission. You can arrive, touch the ground, open the hatch, look out at an entire planet in front of you, and still you cannot simply say, "All right, tomorrow we go home." Not because Mars has an invisible wall around it, and not because lifting off from Mars is impossible. In fact, Mars has much weaker gravity than Earth. So, if we are only talking about leaving the ground, Mars is easier than Earth. But leaving the ground is not the real problem. The real problem is leaving the ground, entering space, changing your orbit around the sun, and meeting Earth at the right place. And Earth is not hanging still in the sky like a lamp you can aim at. Earth is moving. Fast. Home itself has become a moving target. So a very natural question comes up. And honestly, it is the question I would ask first too. If the timing is bad, why not just burn more fuel and go anyway? That sounds reasonable, until you remember what fuel means in space. In principle, yes. If you had enough fuel, enough engine power, enough mass already delivered to Mars, and enough willingness to accept danger, you could design a more aggressive return path. Nature is not building a magical gate in the sky and saying, "You may not pass." The gate is much more practical than that. It is made of energy, fuel, mass, heat, error margins, and all the things engineers had to prepare before the mission even began. If you try to leave Mars at the wrong time, you have to force the spacecraft onto a harder path to catch Earth under worse geometry. A harder path needs more change in speed. More change in speed needs more propellant. More propellant makes the spacecraft heavier. And a heavier spacecraft needs still more propellant to move itself. Very quickly, the problem begins to feed on itself. You do not even need to write down the rocket equation to feel the trap. Imagine packing for a long hike and saying, "I will carry extra water just to be safe." But the extra water makes the plus backpack heavier. The heavier backpack makes you need more food. The extra food makes the backpack heavier again. With rockets, that punishment becomes much more severe. 1 kilogram of fuel waiting for you on Mars is not just 1 kilogram on Mars. It is 1 kilogram that had to be launched from Earth, protected through space, delivered to Mars, landed safely, and kept usable until the day of return. So when someone says, "Just bring more fuel," a physicist hears something very heavy inside the word "just." This is why efficient missions do not try to overpower the solar system by brute force. They wait for the solar system to open a path that human machines can actually afford. And so the astronauts are not waiting because the mission failed. The strange thing is that they are waiting because the mission succeeded in the efficient way. The same path that helped them reach Mars with reasonable fuel also commits them to living with Mars until the return path becomes reasonable again. Landing is not complete freedom. Landing means you have joined the motion of Mars. You have become a small part of that orbital rhythm. And now you must wait until Mars and Earth place themselves into the right relationship for the journey home. That rhythm is not counted in hours, and not in a few days. Earth and Mars return to favorable geometry roughly every 26 months. And in many long-stay mission designs, the crew may have to remain on the Martian surface for about 500 days before the return window opens. 500 days does not sound like a movie disaster. There is no giant explosion, no monster, no steel door slamming shut. But that quietness is exactly what makes it heavy. It is breakfast after breakfast, system check after system check, exercise session after exercise session, message after message sent to Earth. And then a long wait before any reply comes back. They may miss home long before going home becomes a real option. They may finish their first experiments early, but still have to keep living, repairing, checking, conserving, and waiting. If we look at it as engineers, this is a mission architecture problem. If we look at it as physicists, it is a problem of energy and orbit. But if we look at it as human beings, it is a psychological problem. Because the hardest part may not be knowing that Earth is far away. The hardest part may be knowing that even if you want to leave, the universe has not yet offered a practical road home. So the phrase, "You can arrive, but you cannot leave yet," is not a pessimistic sentence. It is an honest one. A Mars mission is not really like drawing a line from Earth to Mars. That picture is too still. It is more like trying to meet two runners on a track. Except the track is around the sun. The runners never stop. And your spacecraft has only so much energy to spend. First you catch Mars. Then you live with Mars for a while. And only later does Earth come back into a position where going home makes practical sense. Once you understand that, the landing is no longer only the ending of the journey. It becomes the beginning of a different kind of test. Not the roar of engines anymore, but the steady hum of air filters inside a habitat. Tools being checked every morning. Slow footsteps inside a pressure suit. And outside, a pale red sky where Earth is not gone, not lost, just not yet reachable in the practical language of fuel and trajectory. That is the real trap of Mars. Not only how hard it is to get there, but what happens after you have arrived. You must live inside the waiting. You must keep the machines alive, keep the crew alive, keep patience alive, and trust that the same solar system that made the journey difficult will eventually open the road again. Not because it cares about you, but because the geometry will come back around. And when it does, only then can you try to come home. Once the crew understands they cannot simply land on Mars and leave again whenever they wish, the whole mission changes. Not in a loud way. Not like an explosion. Not like some dramatic warning light flashing on a panel. It changes quietly. The astronauts look around and realize something very simple. They have not just reached another planet. They have entered a place that must now be survived day after day. And that is a different kind of problem. A traveler thinks about arrival. A resident thinks about morning checks. Oxygen levels. water recycling, batteries, seals, filters, dust on the equipment, and whether the habitat will still be healthy tomorrow. That is the part people often skip over. Landing is exciting. Staying alive is repetitive. And on Mars, repetition is not boring. It is survival. Imagine the first few days after landing. There is ground under your feet again, after months of floating through space. That must feel almost comforting. You can look out and see rocks, shadows, a horizon, the shape of a real landscape. Your mind wants to say, "Good, we are on solid ground now." But physics does not care about that feeling. A surface is not the same thing as a home. The ground does not feed you. The air does not breathe for you. The sky does not protect you the way Earth's sky protects you. Mars gives you something to stand on, and then it stops helping almost immediately. The atmosphere is a good example. People hear the word atmosphere, and they may imagine a thinner version of Earth's air. But for a human body, that is not the right way to think about it. Yes, Mars has an atmosphere, but it is mostly carbon dioxide, and the pressure is terribly low. Your lungs cannot use it. Your blood cannot make a deal with it. Your body cannot say, "This is an environment I can live in." To the body, the outside world is almost a vacuum with dust moving through it. That means a spacesuit is not just clothing. Clothing assumes the world is already doing most of the work. A jacket keeps you warm because there is still breathable air around you, and normal pressure pressing gently on your skin. On Mars, the suit has to bring a little artificial earth with it. Pressure for your body, oxygen for your lungs, cooling when heat builds up, communication, and a way to remove the carbon dioxide you keep breathing out. Every walk outside becomes less like a stroll, and more like taking a small life support system for a cautious walk across another world. The habitat is the same idea made larger. It is tempting to call it a house, but that word is too relaxed. A house on Earth sits inside a generous planet. The planet supplies pressure, gravity, air. Weather that may be annoying but is still part of a living world. On Mars, the habitat must argue with the planet every second. It must hold pressure inside, keep oxygen at the right level, remove carbon dioxide, control humidity, manage heat, recycle water, process waste, prepare food, and keep enough power flowing so that all these invisible jobs continue. If one of those jobs becomes weak, life becomes fragile very quickly. So the crew's day may not begin with a heroic speech. It may begin with a reading on a screen, a pressure number, a filter warning, a quiet fan that must keep turning. That is why routine becomes almost sacred there. On Earth, a checklist can feel dull, something you do because an organization told you to do it. On Mars, a checklist is a way of staying alive without having to be heroic every minute. You check the seals because a tiny leak is only tiny if you catch it early. You check the filters because air is not just air when a machine is making it safe. You check the suit because once the airlock closes behind you, the suit is no longer equipment. It is your border with death. This is not the glamorous part of exploration, but it may be the most honest part. Heroism on Mars may look like tightening a valve, cleaning a seal, replacing a worn part before it becomes a failure. It is not theatrical, but it is real. Then there is radiation. And radiation is unsettling because it does not behave like the dangers our instincts understand. Fire announces itself, A falling rock announces itself. A storm can be seen or heard. Radiation may give you nothing in the moment. No sound. No smell. No sudden pain to warn you that the body is being asked to absorb risk. On Earth, we forget how protected we are. We live under a thick atmosphere and inside a magnetic shield. And because we were born there, we mistake protection for normal life. Mars does not offer the same bargain. Its thin atmosphere and weak global magnetic shielding mean energetic particles from space can reach the surface more easily. So the crew has to think not only about air and water, but about invisible particles coming from the sky. The solution is not magical. It is almost embarrassingly physical. Put mass between the body and the radiation. Water can help. Supplies can help. Habitat walls can help. Perhaps even Martian soil can help. I like that image because it brings the whole mission back down to simple physics. You cross interplanetary space with rockets, computers, navigation systems, and all the cleverness human beings can build. Then you arrive and discover that one of the oldest ideas still matters. Put something thick between yourself and the danger. The dust under your boots may become part of the wall that keeps you alive, and dust itself would not stay innocent for long. At first it looks small, almost harmless. Just powder, dry, fine, lying on the ground. But machines do not judge danger by drama. Dust can cling to surfaces, creep into joints, cover solar panels, scratch seals, and reduce performance little by little. That is the frightening thing about it. It does not have to destroy the mission in one grand event. It can simply make everything slightly worse for a long time, until slightly becomes seriously, and seriously becomes dangerous. Mars does not need to attack like a monster. It can wear things down patiently. Power sits underneath all of this. Without power, the habitat stops being a habitat and becomes a sealed object in a cold desert. Power moves the air, cleans the water, runs the computers, keeps temperatures within human limits, charges suits, keeps communication alive. It is easy to talk about power as if it were just one engineering category among others. But on Mars, power is the pulse of the base. Solar panels may be useful when the light is good, but dust and storms can dim that light. And a mission that has to survive for hundreds of days cannot be built on the sentence, "It will probably be fine." Steadiness becomes precious, not because it is exciting, but because living things depend on boring reliability. Still, I think the hardest part may not be any single machine. It may be the length of the waiting. 500 days is an odd kind of time. Too long to feel like a visit. Too short to feel like a normal life. The crew is caught in between. They are not traveling anymore, but they are not home. They are not trapped by a locked door, but they are not free to leave either. Every morning they wake up under the same knowledge. The return window is not open yet. So they work, exercise, repair, measure, wait. Not because waiting is passive, but because on Mars waiting has to be maintained. Even Earth feels different from there. The crew can talk to home, but not in the ordinary human way. A message takes time to cross the distance. A question does not get an immediate answer. A joke arrives late. A worry has to sit there for a while before anyone on Earth can respond. That delay changes the feeling of conversation. Earth is present, but not present enough to rescue the moment. It can advise, calculate, comfort, and listen. But it cannot reach through the airlock and fix the thing in front of you. So the crew must become a very small society. That may sound soft compared with rockets and radiation, but it is not soft at all. In a small habitat, every habit has weight. Every disagreement lasts longer. Every silence can become heavy. On Earth, you can walk outside and let the world absorb your mood. On Mars, the outside world does not absorb anything. It waits behind a suit, an airlock, and a checklist. So patience becomes part of the life support system too. Not the kind with wires and valves, but the kind without which the wires and valves may not be enough. And yet, we should not turn Mars into only a horror story. There would be wonder there. Real wonder. Imagine being the first person to pick up a rock on another planet and know that no human hand has ever done that before. Imagine watching a sunrise under that thin sky, not as a picture from a rover, but as a tired person standing inside a suit, hearing your own breathing while another world brightens in front of you. That matters. Humans are not better than machines in some magical way, but a human being notices things restlessly. One question becomes another. One strange rock becomes a walk. One walk becomes a new guess about the planet, but the wonder never cancels the constraint. Every trip outside must come back to the habitat. Every sample must fit inside procedure. Every discovery must share time with power limits, safety margins, and the health of the crew. Mars can be beautiful and still be incompatible with the human body. That is the truth the mission keeps teaching. The crew is not simply counting days until departure. They are holding a fragile balance together while Earth and Mars continue moving around the Sun. And then, after many months, the geometry begins to help again. Not in a way you can see by looking out the window. The rocks look the same. The dust lies the same. The sky does not announce anything. But in the calculations, something is changing. Earth and Mars are moving into a relationship where the return path becomes possible again. The crew has lived inside the clock for so long that this permission must feel strange. The planet has not become safe. The machines have not become unnecessary. The risk has not disappeared. But the mathematics finally opens a narrow door. Leave now, or wait again. The return does not begin like a movie scene. Nobody on Mars suddenly hears music rising in the background. Nobody looks out through the window and sees the planet become kind. The rocks are still the same rocks. The dust is still lying on the equipment in that stubborn Martian way. The sun is still pale, small, and a little far away. But somewhere inside the habitat, on a screen full of numbers, something begins to change. And that is the part I want you to notice. Because the crew is not waiting for Mars to give them a sign. They are waiting for geometry to stop being cruel. Earth has moved enough. Mars has moved enough. And for a short time the two worlds make a path that a machine can actually use. Not an easy path. Not a safe path in the ordinary sense. But a possible one. And in space travel, possible is already a very serious word. This is a strange kind of freedom. Because on Earth, freedom usually means you can decide to leave. You can leave a room when you feel tired. You can leave a city when the work is done. You can change your plan because the weather is bad or because your heart has had enough. But Mars does not care about that kind of freedom. Mars does not say, "You are finished now. Go home." The planets are moving whether you are ready or not, and the return window is not something the crew owns. It is something they enter while it exists. That sounds simple until you imagine missing it. Missing it is not like missing a bus. It may mean waiting months while Earth runs ahead in its orbit, while Mars carries you with it around the sun, while the little road home closes again without making any sound. So the ascent vehicle sitting on the surface is not just a machine. It is a promise, but a promise made of valves, tanks, seals, wires, software, and every small piece that cannot be allowed to behave badly. On Earth, if a launch fails, the result is terrible, expensive, maybe tragic. But on Mars, a failed launch is something colder than that. It may remove the only road back to the return craft waiting above the planet. That is why the crew checks everything again, and then checks the checking. Not because they are panicking. Panic is not useful there. Fear has to become procedure. It has to become a hand moving carefully over a checklist. A pair of eyes looking one more time at a pressure reading. A quiet voice confirming what must be true before the engines are allowed to speak. And then the engines ignite. There is no romance in that first second. Only force, vibration, acceleration, and trust placed into machinery. The surface begins to fall away beneath them. The habitat shrinks. The red plane becomes a shape, then a color, then part of a world below. They are not leaving because Mars has become safe. They are leaving because the risk is finally pointing in the right direction. The vehicle climbs through the thin air, reaches orbit, finds the return craft, and now docking is no longer just a technical maneuver. It is the moment when all those months of waiting have to meet one exact piece of celestial timing. A small mechanical handshake above a planet that never once promised to keep them alive. But coming home is not simply going out in reverse. That is one of the mistakes we make when we imagine space travel too quickly. We draw a line from Earth to Mars, and then we draw the same line back, as if the human body did not change during the journey. But the crew returning from Mars is not the crew that left Earth. Their muscles have been defended day after day. Their bones have been defended. Their sleep has been defended. Their patience has been defended. They have lived with radiation as an invisible passenger, with delayed voices from home, with birthdays and seasons arriving only as messages. And now they must cross the silence again, not as fresh explorers, but as people who have already spent a part of their lives inside the machinery of survival. The return craft falls around the sun on its long calculated curve, and Earth does not come closer because they miss it. Earth has to be intercepted. That word is important, because home is not sitting still like a target painted on a wall. Home is a moving world, blue, bright, falling around the sun while the spacecraft follows its own path through space. Every day Earth grows a little larger in the window, but even then the spacecraft must obey timing, angle, speed, heat, and the hard patience of physics. You do not reach Earth by wanting it. You reach it by arriving at the right place at the right moment. And when you add the whole mission together, the scale becomes almost uncomfortable. 6 to 9 months going out. Roughly 500 days on the surface. 6 to 9 months coming back. Nearly 3 years can disappear into one mission plan. But 3 years is not just a number in a document. It is ordinary life happening somewhere else. It is people getting older on Earth, children changing their voices, illnesses arriving through delayed messages, news reaching the crew as a signal instead of a room full of people. Distance becomes time, and time becomes something the crew has to carry. So maybe the hidden trap of Mars is not that we cannot go there. We can go. With enough engineering, enough courage, and enough respect for the numbers. The trap is that arriving is not the same as being free. You can stand under that pale sky. You can touch the dust. You can collect the rocks. You can live inside a small pocket of earth made by human hands. But you cannot leave simply because the story feels ready to end. The path home must open first. And that is what Mars teaches if we listen carefully. Not that humans are weak. Not that exploration is foolish. But that nature is not conquered by confidence alone. We move through it only when our courage is disciplined enough to do the arithmetic honestly. When Earth finally fills the window again, it will not look like an ordinary planet. It will look like air without machinery, water without recycling loops, gravity strong enough to feel like belonging, and sky thick enough to protect skin and blood. That is the quiet lesson hiding inside the Mars dream. The journey outward shows us how far humans can reach, but the journey back reminds us what kind of world made us possible in the first place. So yes, we should look toward Mars with wonder, but also with humility. Because the universe does not reward loud ambition, it rewards careful understanding, patient work, and the honesty to admit that even the road home is something we must wait for. Thank you for traveling with us through this quiet machinery of worlds, and may we keep looking upward with courage, with patience, and with respect for the physics that lets us move at all.